All right, so we start chapter 3 today, which is all about, like, eventually we get into parallel lines, but today is about some special angles, and then we're going to get into parallel lines, and then we're going to get proofs about parallel lines, perpendicular lines, that kind of stuff goes out throughout the chapter. So a plan for what's coming next at you, we're going to do 3-1 today, 2 tomorrow, 3 on Friday, review Monday, and then you'll get a quiz on those 3 sections next week, okay? So chapter 3 is also one of probably the most applicable things in geometry. Like, it is one of those lessons that you tend to see on standardized tests a lot, are these special angles, okay, as we get into it. The section 1 is a foundation of a lot of vocab, and then as we move forward, we get a little bit deeper into it. But chapter 1, section 1 is called Identifying Pairs of Lines and Angles. So it starts with the difference between parallel versus skew. A lot of people have heard parallel lines before. And the definition of those parallel lines are coplanar lines that do not intersect. So a lot of people know them as lines that don't ever touch, but they also have to be coplanar. They have to lie in that same plane. Skew lines also don't intersect, but these are non-coplanar. Skew lines also don't intersect, but they have to be non-coplanar, so they can't lie on the same plane. So when you're picturing, like, the difference between the parallel lines and the skew lines, like, if you think about the lines on the floor, okay, if they are running forward to back or left to right, those would be parallel lines because they all lie on that same plane. But a line in the floor that maybe runs, like, from the TV to the back wall, and then a line on the wall over there that runs up and down, those would be skew because those are two different planes. The ground and the wall, two different planes, okay? But they also have to run in, like, different directions. I can't say the line, you know, in the bottom of the floor here and then at the edge of the wall over there that runs in the same direction because those would be parallel.
So, like, that picture, I see that they're not hitting.
Right. So neither of these are going to intersect each other, though. So a parallel, they would run on the same side of a box or the same type of, like, a plane. So the ground, the ceiling, the wall, anything like that, they would run in the same direction so they'd never touch. They'd be the same distance apart the whole way. They never touch. But the skew, one's going to lie in one plane. So, for example, this one is, like, lying on the floor, if you will. And then this one would be passing through, but going up and down so that it doesn't intersect that first line, but it also can't lie on that same plane. Parallel planes are planes that don't intersect. So if you think about a box being a representative of a bunch of different planes, like the front and the back of that box would be parallel. The top and the bottom would be parallel. The right side and the left side would be parallel. So if I was using this one and I asked you to give me the name of a plane that is parallel to ABH, you would tell me what? Say it again. FDE could work. And the way we show parallel is literally two tall parallel lines. If I asked for a plane parallel to AGF, you would tell me it's what?
BHE.
BHE could work. So left side and right side.
Can it be BCE?
It can be BCE, yep.
So how can you leave out
because it just needs to be 3 non-collinear points. Yep, it's a plane. All right, so 2 postulates pertaining to this stuff, and that is the parallel postulate and the perpendicular postulate. These have names, so you can use these names. The parallel postulate says if there is a line and a point not on that line, then there's exactly one line through the point that is parallel to the given line. The perpendicular postulate says if there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So if you were to, like, pick apart what this says, the first one says if there's a line and a point not on the line, there's exactly one line through that point parallel to the given line. So if I draw a line and then I pick any point, let's say I put it above it, I put it below it, doesn't matter, somewhere above or below it because it can't actually be on that line. And I ask, like, each of you to go to the board and try to draw a line through that point that is parallel to that line. And I'm not talking length of a line because it goes on forever. Yours only one that works, okay? And the way we would show parallel is these little arrows that are either solid like that or they just have the little arrow tick mark, but those would be parallel, okay? There's only one line that can be drawn through that point. That would be parallel to the initial line.
I know this game. I'm kidding.
Okay. The second one says that there is through a line and a point not on the line. There's only one line that can be drawn that would be perpendicular to it. So again, we're not talking about length because a line goes on forever. But there's only one way to draw that line that would be perpendicular or meet at 90 degrees with that bottom one. So that's what those postulates mean.
There's always like infinite lines, right?
Like in the world,
Like,
in
no,
space.
No, in that, like, can there be a line that goes every direction?
With one point, yes, but not with these. The parallel, no, it's only one, and the perpendicular, no, it's only one. All right, a transversal is defined as a line that intersects two or more coplanar lines in different points. Transversal is a line that intersects two or more coplanar lines in different points. All right, so in this diagram, the M is the transversal because it intersects two other lines. So J only intersects one line, K only intersects one line, but M intersects both. So we would say that M is the transversal, or line M would be the transversal in this diagram. The interior angles are the angles in between the other two lines. So everything in between those two would be called interior angles. So in this diagram, angle 3, angle 4, angle 5, and angle 6 are your interior angles. They are in between the intersected lines. And then the exterior are the ones on the outside of those two lines. So in this case, it's 1, 2, 7, and 8. Again, think interior in between, exterior would be on the outside. All right, some more vocab. So there are 4 special kinds of angles that are found when you have two lines in a transversal, okay? The first are alternate interior, and these are two non-adjacent. What does adjacent mean? Next to. So these are two angles that are not next to each other, that are on opposite sides of the transversal. And they are interior, so they are in between. So 3 and 6 are alternate interior. And 4 and 5 are alternate interior. They are on opposite sides of the transversal. They are not next to each other. And they are in between the...
Angle 3 plus angle 6.
If you're listing them, it would, no, that's not a plus, it's just an and.
Oh.
Yeah. The alternate exterior are now, again, not next to each other. And they are on opposite sides of the transversal on the outside. So 1 and 8 are alternate exterior. And 2, actually that color's too close. And 2 and 7 are alternate exterior. So in between means interior. Those would be 3 and 6 and 4 and 5, obviously not next to each other. And then the exterior on the outside, alternate 1 and 8, 2 and 7. Good so far. Okay, then comes same side interior, which is also called consecutive interior depending on the book, which is two interior angles on the same side of the transversal. So they have to be interior and they have to be on the same side. So 3 and 5 would be same side interior, and 4 and 6 would be same side interior. And then the last are corresponding angles. And these are two angles in corresponding positions relative to the two lines. The easiest way to identify corresponding would be to make yourself like a little box that goes around the intersection, because these are going to get turned in different directions. And the top left in the first box is corresponding to the top left in the bottom box. So angle 1 and angle 5 are corresponding. The top right in the first box and the top right in the second box would be corresponding. So angle 2 and angle 6. The bottom left would match the bottom left. So angle 3 and angle 7. And the bottom right and the bottom right. Angle 4 and angle 8.
What was the difference between same side interior and corresponding?
Same side interior is in between the two lines,
Yeah.
and on the same side. So 3 and 5 are same side, and 4 and 6 are the same side. And there's only 2 pairs, right?
Yeah.
Corresponding, there are 4 pairs because you make that little box, and the top left one's going to match the top left. The top right's going to match the top right. The bottom left to the bottom left, and the bottom right to bottom right. All right, so here's some true or false. Classify as true or false. All right, so A says a transversal intersects only parallel lines. True or false? False. Okay, they can be any kind of lines, just 2 or more. B, skew lines are not coplanar. True or false? True. By definition, they are non-coplanar that don't intersect. C, if 2 lines are coplanar, then they're parallel. False. There are lots of kinds of lines that can be coplanar, right? Like if I have a plane, this line and this line can be coplanar. They're intersecting. They are not parallel, right? Perpendicular lines would be coplanar that also are not parallel. And D says if 2 lines are parallel, then exactly one plane contains them. True or false? True. Okay. That would be like having 2 points on a line and then a point not on the line, right? That would say only or exactly one plane contains them. Questions on those? All right, example 2 says think of each statement in the figure as part of a line. Each segment, sorry, in the figure as part of a line. Which line or planes appear to fit the description? All right, so what line is parallel to CD and contains point A? Santi. Good. Line AB. You got to give it the line over it, or you got to use the name line, okay? B says a line is skew to CD and contains point A. Mateus. AH. Good. Line AH. C says a line is perpendicular to CD. So again, that same line and contains point A. It would be, Jonathan. AD. What'd you say? Line AD. AD. Good. And D, plane parallel to plane EFG, which is that bottom plane containing point A. Go ahead. A, C, D works. A, B, C works. B, C, D works. Like any combination of those.
Could you flip them around?
Yeah. Like the order? Like DCA?
Yeah, like on C, I put DA.
Yes, as long as it has a line over it. Yep. Okay. All right, last example, and it says to name the given angles based on that diagram. So again, if you do it, we'll go over it. All right, so give me one pair of alternate interior angles.
3 and 6.
Go ahead. You said 3 and 6. That works. Santi, give me the other one. 2 and 7. Okay, B, consecutive interior, which remember is also called same side interior, but consecutive interior. Give me one pair. Kala. 2 and 3. What's the other pair? Kumar. 6 and 7. Good. Corresponding angles, and remember now there's 4 pairs here. Jonathan. 1 and 3. Mars?
6 plus 8.
6 and 8. Oh. Jonathan? 5 and 7. And last one, go ahead. We got 6 and 8. The last one is 2 and good. 2 and 4.
So why can't it be 5 and 8?
Because those are not corresponding. Because look at, if you make the box, right? 5 is bottom left. That means 7 is bottom left. All right, now alternate exterior are? What matches 8? Well,
1, 8,
okay, what matches 5?
4.
Good. So on the, you'll see when you go into big ideas, like the questions that pertain to this, some of them are like a check all that apply. So if it says alternate exterior and there are 2 in that list, you have to check them both to get it right. Okay, if it says corresponding, you would check them all. The only, and that's really like the most of big ideas is just looking at the diagram and identifying stuff like that. There is one that it's going to give you, like it'll give you a diagram, and it, let's say this is 1, 2, 3, and 4, and you did something like this on your test, except it didn't give you the diagram. And it said angle 1 equals, let's just say it's 50 degrees. And then it wants you to find all of the other measurements, right? So if this is 50 degrees, what other angle do I know right off the bat without having to do any work whatsoever?
3.
3. Angle 3 is 50 degrees, and why is that? They're vertical angles, okay? Then I have 2 other angles, but it does like there's a relationship formed there, right? 1 and 2 would be called what?
Supplementary.
They're supplementary, but what are they called? Linear pair, which means they are supplementary, so then 2 is what?
2 is 130.
Good, and 4 is also 130,
So how
okay?
come, like, we know it's 130? Like, why can't this be like, is it not a variable?
No, because you can find it. If you have its linear pair measurement, that means you have its supplement measurement, so you have to just subtract it from 180 and then you can get it. Calla. No. So there's nothing that you have to like set up an equation this tonight. There's nothing like that.
No working on ability?
Correct.
Yes.